This lesson is on absolute value inequalities. Before we begin, I'd like to just take an example. So let's say you had x absolute value less than 2. So the question is, what are all the possible values that you could take the absolute value of and you'd have an answer less than 2? Well, let's think on the number line. If you took 2, well, this one's not including 2, so it's all the way up to 2, 1.9, and smaller. All those numbers will obviously be less than 2, all the way up to 0. But then what else? Can we have -1? Well, -1, if we plug it in, we'll have 1 less than 2. Okay, we'll keep going. How far is it going to go? Well, it's going to go all the way down to -2. So you'll notice that the absolute value of an expression, if it's less than a number, it'll be between the positive and the negative of that number. So that would result in x being between -2 and 2. If you had absolute value greater than 2, then you'd have the exact opposite of this. So your endpoints in this case, because it's open, would still be open. However, everything in between -2 and 2 is going to be less than 2 as an answer. So you want everything out on the outskirts. So think of all these numbers here, less than -2. All of those numbers will, when plugged in and absolute valued, be greater than 2. Same with everything that's bigger than 2 already. So this results in x being less than -2 or x being greater than 2. So let's take that and generalize it. We have two types of absolute value inequalities. One, less than, is going to be between the negative and the positive value. And the greater than will be on the outskirts, either less than the negative value or greater than the positive value. So let's take those two items into context, into some examples. This first example has an absolute value of an expression less than 5. So that means that that inside is going to be between -5 and 5. Because to be less than 5, you need to be between -5 and 5, like that. Alright, so we just put that expression in, and there you go. Now we can solve it by doing the same thing to all three sides. We can add 1, and we do that by deciding that x needs to be alone. What do we need to do to it? X, we first have to add 1. So we have -4 less than -2x less than 6. We can continue. Now you see we need to divide by -2, but when we divide by a negative, we need to switch the signs of our inequality, right? So to switch the signs of the inequality, we can switch them like this first, but you'll notice that this does not quite follow the pattern of how we write things normally. It still makes mathematical sense, but it's nicer to rewrite it as x being between -3 and 2, and that way these numbers are in order. It's easier to graph as well. You know that anywhere between -3 and 2, all those values should result in satisfying this inequality. So you can try some numbers in here and test it out. And in interval notation, this is -3 to 2. All right, now let's try a greater than question. This one's greater than or equal to. So now our endpoints are going to be including points, not excluding open points. So remember, when it's greater than or equal to a number, it's on the outskirts. So in this case, including. So our x minus 2 over 3 could be less than or equal to negative 4, or it could be greater than or equal to positive 4. We've got those two options. Now let's solve each of them and combine using the OR statement, which is a union. So here we can multiply both sides by 3, and we get x minus 2 less than or equal to negative 12. Add the 2, you get x less than or equal to negative 10. Next, we have also multiplication by 3. We get x minus 2 greater than or equal to 12. Also add the 2, and now we have x greater than or equal to 14. Okay, so we've got either that statement or that statement. So that means we union them together on one number line. X can be less than or equal to negative 10, or x could be greater than or equal to 14. In interval notation, you'd have negative infinity all the way up to negative 10, including, or 14, including up to infinity. Sometimes the absolute value is not isolated, so you need to isolate the absolute value first. In this case, we've got a negative multiplied to the absolute value, so we should divide by that negative 1 on both sides. But when we do that, we need to switch the sign as explained in the inequalities video. So we've got 2x minus 3 absolute valued, but when we've changed the sign here, we change the sign here, and the sign also changes in the middle. So now we've got our less than or equal to 7, and remember, when we're solving an absolute value question less than, it's going to be between negative 7 and 7. So we've got our 2x minus 3 between negative 7 and 7, and now we solve that. So we can add 3 to all three sides. So we've got negative 4 here, 2x, and 10. And we can divide all three sides by 2, leaving us with negative 2x and 5. So our final answer will be that x's need to be between negative 2 and positive 5. No signs were changed because there were no divisions by negatives. And in interval notation, we can write negative 2 to 5, including both. All right, let's take a look at this example here. We also need to isolate the absolute value here, so let's subtract the 5 first. So we've got 1/3 x plus 7 absolute value greater than 6 minus 5, which is 1. So now it's greater than, so it's either less than negative 1 or greater than 1. It's on the outskirts. It's not between the positive and negative. It's on the outskirts of the possibilities. So let's break it up into two equations. We've got 1/3 x plus 7 could be less than negative 1, or 1/3 x plus 7 could be greater than 1. Now we can solve both of those inequalities. Subtract 7 is negative 8. Multiply both sides by 3, and we get negative 24. Subtract 7, negative 6. Multiply both sides by 3, and we get negative 18. So when we put both of those on one graph, we get x's are less than negative 24, and by this we mean or, x's are greater than negative 18. So we can write that using interval notation. And there you have it. There's a couple special cases to check out before we check out. So let's take a look at the first one, absolute value less than -8. Well, can an absolute value be negative at all? No. Therefore, there's no solution. What about this one? Well, we need to isolate the absolute value first. So we've got over -2 over -2, but we've divided by -2. So we need to change the sign. That's going to give us absolute value 3x minus 4 greater than -8. Now, when is an absolute value greater than a negative number? Well, if we look at what greater than -8 means, that means everything greater than -8. But we know that everything up to 0 won't work. But everything greater than 0 is fine. It'll satisfy this inequality. But isn't absolute value of anything always greater than or equal to 0? This would mean that x could be anything. Therefore, the solution here is all real numbers.